Yeah, I don't know if I can eliminate the bottom bar, but for now, let's keep it like this. Okay, so one final check on Zoom. Can people who are remote hear me?
Yeah, Professor.
Yes. Yes, Professor.
Okay, there are people responding there. Okay, so thanks. So people who wanna send me a direct message, don't send it to direct. Don't send it. So don't send a direct message because it's being displayed in the class. You can email me or raise your hand or something, perhaps. But don't send me a direct message. But we can see your chat messages directly. But of course, if you wanna contribute something to the general discussion, you can always unmute me yourself. Yeah, I know you had a question whether it was hybrid. It's not hybrid, so I don't know why some of you are not here. But this is an in-person class. Okay, we only have about 7 lectures, so we are already quite time crunched. With that, let me get started. Okay, so in terms of logistics, there's actually not much other than me asking you questions in terms of, is everything clear in terms of the logistical details for this course? It's as written in this page. It's actually, let's, to keep it simple, the way I've laid out is there are a few lecture sessions, which is we are in lecture number 2 today. There are going to be a few more lecture sessions. The key activity that you will do in this course is actually a project, which is related to trying out these tools, which are not the types of tools you would see that's in the database class or in the big data class or even in 572 or 575. The point is just to try out something else beyond those tools that you see in those courses. Okay. So in terms of logistics, it's actually in person for the next few weeks, and then there is going to be a final slot for student project presentations. Okay. Currently, I've suggested it's online only, figuring out what's the situation COVID, but we'll see how if it can be in person. Okay. So with that, I'm going to get started with the topics. I'm going to kind of recap, again, give you a gist of the overall picture of this course, because once you step out of just building machine learning models, there's actually too many directions. Okay, I mean, and you'll see when we do go through this lecture as well as the other lectures, there are many directions, and to consolidate all of that into a book form or in terms of current set of lectures, you will inevitably miss out some very big topics. Okay, and so the course has been laid out where it's basically in these 4 parts. The first part is about you train the model, you train a machine learning model any way you can, like in a local machine or internal to your company, some maybe a a good compute machine and so on. You somehow develop it offline, and then the first part is all about how to make it serve. So how to serve it online. Okay, online just means connected to the internet essentially, and so we pick up a pre-trained model and then do a few things. If you see the 3 bullet points, think of a line, and then on one end of the line is like the web server idea. All of them are servers at the end of the day, but one end of the line is the web server idea, where you do everything from scratch. You kind of instantiate a compute instance, you read the model from somewhere, maybe it's locally available, you start a web service, you kind of build the use a web, typically a web app framework, to load the model and then serve it directly to the internet or to other teams or whatever, some external use. That's one end. The other end is what we'll see today, and in fact today is purposefully kept light so that if there are some other hiccups that we saw in the first lecture, then we can resolve them as we look at today's content. Today is mostly just about serverless solutions. Okay, serverless solutions. They still involve servers behind the scenes, which will be able to make predictions given inputs through this request response idea that we saw last time, and we'll maybe briefly recap it. But all that actual deployment specifics is hidden behind the scenes. Okay, so you just have to get familiar. You just have to set up a Python script or Python, essentially a function actually, in an appropriate runtime environment. So we'll just use Python 3.9 or whatever is the appropriate one. And then in that environment, and we'll see how to do that, we just need to specify our function. We don't have to worry about starting a AWS EC2 instance, or increasing its security by setting up a firewall or opening ports. I mean, we have to do some minimal aspects of this, but it's all automated behind the scenes. So we just have to. It's like a very simple user interface so that you can focus on your function and not worry about anything else. And that function is going to just read a model and get a request and execute the function which corresponds to your model, and then give out a response. Okay, that's the other end. So web server from scratch is one end, serverless is the other end. In between is this whole idea of Docker or containerization. Docker, its variants on many containers, including Kubernetes and all that. So they sit in between. So because they're not like complete full virtual machine or a bare machine and running a server from scratch, which is the first point. Docker is in between, where you write the Python script, you write a Python function, which makes the model predictions, but you also kind of wrap around it some additional things, and those things are, by the way, behind the scenes, in the sense that we'll just run some commands where your Python script is embedded into what is called an image. Okay, it's called a contain, from which you can run this particular script anywhere essentially. And we'll talk about those ideas when we get there. Okay, so it's basically like containerizing just means kind of isolating your script, packaging it in a nice way, like in an Amazon box, and then ship it to whichever location you want, whether it's a Mac OS based server or a Windows based server or a server sitting in California or in Germany, and it doesn't matter. Okay, the operating system also almost doesn't matter, and you should be able to deploy, as in the program will run. It's like that some programs only run on Windows, some programs only on Linux. So it's like that it's like that portability. That is what is is what you get. And so some people prefer that. Okay, completely serverless, you lose some control. Completely web servers, you have a lot of control, but you may not be an expert. So in between potentially has some advantages. It also has disadvantages, but it works well with the current state of software engineering as well. So it's not specific to machine learning. All these three ideas, by the way, web servers, serverless, or Docker, but we will be just using them for deploying machine learning models. The second part is about scheduling models so that they retrain. So this is now stepping away from the batch training idea, the manual training that you did in a Jupyter notebook or equivalent. So this is really about fetching data every day from maybe an application database that keeps on appending data to itself, run an updated model and deploy it, push it somewhere. Okay? So that retraining, versioning, as well as A/B testing. Okay, models are not just deployed. So here by testing, I don't mean unit testing or integration testing, which is what you see in software engineering. Here I'm talking about testing machine learning models themselves. And so we do A/B testing, which is randomized control trial, basically. And so we don't deploy model directly. We have some pre-existing model or heuristic to do something like recommendations. A new model is slowly rolled out based on whether it does well in a split test, okay, or an A/B test. So that's the second part. Third and fourth parts are just more about data engineering, actually, which is why I guess the phrase is being used these days. The third part is actually related to the big data course 560 or 561, I think. So it's more about distributed data processing when data doesn't fit into a single memory, okay, the single machine memory. So although in the first part we talk about Docker and all that, the so whatever Docker, let's say the container has to run on some machine, that machine's limitations of, let's say, RAM of 128 gigabytes, or CPUs, like the 32 cores, that's kind of the limit. Okay, so if you want to extend beyond that limit, you have to do something distributed. And so distributed data processing, in particular Apache Spark, is one example of being able to deal with terabytes of data, where each individual machine doesn't need to have terabytes of memory or anything like that. Okay, and the last part is what's called streaming or real-time infrastructure. Is just an idea about different services or different, I guess, components. Like one component could be making predictions, the other component could be fetching data, the other component could be sending data to the prediction model. So they may all be running at different speeds. They may be in different languages. There's lots of incompatibility the moment softwares have to talk to each other, different pieces of software. And so there's a nice streaming idea where the softwares which want to get information, like maybe get a prediction for, send that request feature vector and a request to what is called a broker, send that to a queue. Basically, what is a queue is just you queue up all the requests, and slowly a prediction service will pick up these requests and make a response and put it back there, and then somebody else will take it. So it's some idea there. So those are the 4 parts. Okay, so let me directly get to so okay, let me actually quickly recap the key idea which will be there not just for serverless today, but also for Docker, to, which is next, Docker and container ideas next time. Is the idea that at the end of the day, if we deploy, how are we going to interact with it? And for the purpose of this course, we have just picked up a simple protocol, the HTTP protocol. So in that sense, the server, whether it's a web server or a serverless service or a Docker-based service on one of the cloud providers, it doesn't matter. For all of them, we're going to make requests using either get or post. Okay, there are particular verbs that we're using. They're part of the HTTP protocol. Okay, and the server is going to respond with appropriate, text string or prediction class, or a numeric value or whatever it is, either as a JSON object, which is just a dictionary, Python dictionary, essentially. I mean, informally speaking. So we're gonna kind of rely on this type of an interaction with the deployed model. Okay. Last time we actually just saw spinning up an AWS EC2 instance in the class. You can also do the same with Google Cloud Platform as well, or Azure, or there are many other vendors today. Or if you don't want to give your credit card and do that stuff, at least for last lecture, you can try things out in VirtualBox. Actually, if you don't want to, like today's lecture does depend on these cloud vendors, but if you don't want to use a cloud vendor, for whatever reason, then you can actually use a VirtualBox and a virtual machine that you can run in your own laptop. That's like a second computer that you have access to. Okay, so your local machine laptop is one machine, which is just local machine. Via VirtualBox, you can virtualize and run a different operating system like Ubuntu that we chose last time for the AWS EC2 instance. You can run that locally. Okay, so that will become a second machine that you can think of that as a remote machine and then just interact with it to deploy a model. Okay. So last time we did look at Jupyter Lab. Jupyter Lab is just Jupyter Notebook. It's all same family. Pandas, I don't know if you saw PyTorch, but we saw Pickle as a way to serialize data Python objects. Very useful, and request library to make requests to a web service, any web location. In fact, you can request a response from google.com, for example. You can do that programmatically using request package. And then finally, Flask is just one example of a micro web framework. There are many others in Python language. There are many in other languages, in Go, or Ruby, or other languages. But we'll just stick with Flask for this time. And there are several command line commands that we saw. Okay, most of the commands will not work on Windows, and so I'm going to take about 5-10 minutes just talk to you guys about what are you using, because that's the biggest hurdle. Once you get through and get access to either EC2 machine through PuTTY is one way, or Windows Subsystem for Linux. So there are some ways to get to a remote machine, this EC2 machine. Once you get there, then all these commands should work there. I mean, you should think of that machine as your experimental machine and not your own local OS. Okay. It was free, but you had to put in a credit card. I mean, it was free in the sense that if it's the first time you're signing up for AWS, it's free for 12 months, I think. Yeah. Any questions about this part? And we'll actually, what we're going to do is not directly jump to um, serverless services, but we'll actually deploy a Jupyter server on that machine so that it can keep running. And this is what I was alluding to last time. So I think last time you saw me having a Jupyter notebook, Jupyter lab running locally. Okay, instead of running it locally, that's because I'm on particular operating system. You can also run it locally using, for example, Anaconda distribution or directly using Python on Windows and Mac. But the idea was that if you run Jupyter Lab on that remote machine, it can keep running, 24x7. You can always disconnect and connect to it whenever. And from there, you can always, connect to any other machine or any other service and so on. Okay. So is the context clear? I mean, I try to quickly recap instead of showing all the pages from chapter 1. Is there any question from chat? Okay, so now I think I have quick questions for you guys in terms of this poll. How many of you have tried AWS EC2 launching an instance and connecting to it? Because that was part of the lecture. Okay, a few of you have tried. How many did other people try something else at least, like unsuccessful? How come? Okay, so were you trying to follow the lecture video and you still had some issues in between? Okay, so we have a TA for this course as well as I'm available. I mean, my office hours is right after this, so we can fix that because see, the first hurdles that I foresee are mostly people working on Windows, kind of not happy with these commands. That makes sense, and so there are some solutions there, and then getting familiar with connecting to a remote machine and getting familiar with Jupyter. And so we'll set up Jupyter today on the remote machine so that you can always access it anytime. So who's not using Windows, or everybody is using Windows? Okay, not using Mac folks. At least you have a terminal. You can also install iTerm2, which is a third-party terminal. Makes it a little bit visually nicer. There are other terminal solutions also called Hyper and so on if you want to use it. If you use VS Code, actually let me mention. Okay. Where is, yeah. So this is a interface for VS Code. Yeah. So if you have VS Code on Mac, you can also get a terminal, which is, I think, command tilde, command tilde at the top. So, yeah, but I'm not going to use VS Code in this course. But people, if you're interested in VS Code, you can. You can actually run Jupyter notebooks directly from VS Code as well. So you don't have to use Jupyter Lab, and you can use VS Code to connect to remote machines as well. With that said, let me actually come back to the slide deck. Yeah, so let me come back again. So Mac people, any issues with commands or connecting to AWS2 machine? No? I would say so Mac, since it's close enough to Linux, so if you install Python, let's say Anaconda Python or something like that, then you're pretty much fine. There is no additional setup needed. Actually, there are some additional tools that we'll use, like AWS CLI. So there's some AWS specific tools or Google Cloud specific tools. You can install them on Mac, but the installation procedures are slightly different. But what I'll recommend is what I'll show today, which is we had spun up an EC2 instance last time. we're going to continue with that. Okay, so we're going to, last time what we did is just run a Flask app and just see some, hey, this is the input, this is the output. But today we're going to, on that remote machine, install Jupyter as well. And so that, everything is uniform. So everybody, as long as you can get to that remote machine running, and as long as you can run Jupyter there, then everything is uniform across the board. Okay, so that's the preferred method. But if you don't want to do that, then Mac is easy because it's kind of shares some of the commands. Windows is the one which requires a couple of more steps depending on how mature you are with working with Windows, at least on the development side. The simplest solution is to install Putty and maybe Cygwin to work with this remote machine. So Putty is just an external third-party tool for you to connect to the AWS machine. And Cygwin is a way for you to get port forwarding so that you can actually look at the Jupyter server on your own browser, local browser, like Edge or whatever you're using, Firefox, Chrome, that's all. Okay, those are two things that you need. Yes. Then it's pretty much the same. Yeah. So we're gonna run Jupyter there, and then once you're there, it's the same command, for everybody. Yeah. So, but we'll do that right now. So, any questions? Okay. So let's do that. Okay, so I'm just coming back to the okay, so Harshit has done it well. Okay. Okay, so I'm coming back to this interface. As you can see, we just have EC2. So today we'll actually use this interface again because we want to use cloud functions. But for now, so I had this instance. Actually, you can see that the instance is in a stopped state. So actually, I need to probably change the state to start. So it's the same instance from before. So I'm not going to redo the steps. So I think an example of that we can do the same thing in 100 different ways. The professional way to kind of deal with these resources on AWS, for example, is to use something called CloudFormation, which is a infrastructure as a code idea where you write down, just like Python scripts, you write down, hey, I want an EC2 machine, and then I want SSH enabled, then I want this and that. You write it as a sequence of steps as a script, and then you say, hey, execute the script, and it will set it up everything instead of using GUI or using other tools. Okay, that's one example of achieving the same thing but using multiple ways. Okay, so okay, in the meantime, let me switch over to so what we're really gonna do and is just create a so we already did this last time. We created a Python environment. I don't remember if we did Miniconda or not. If we did, we have a Python. We anyway had to execute a Flask script. It's just that Ubuntu comes with its own Python version, so you could just directly run it with Python. Mac also comes with its own with its own Python version, but it's always good to install the version that you want. Okay. Let's see if it's still initializing. Yeah. So as I said last time, this is a class where it's more interactive and hands-on if you do it, if you can in real time. If not, at least clone the repository and look at the examples. Okay, today we're going to look at let's see. So last time the relevant examples were these five. Okay, all these five examples are relevant for us to deploy something. Okay, in this case, last architecture-based web services. Three of them are related to, I guess, three of them are related to machine learning models, regression, recommendation, and ImageNet, and the other two are just a simple Flask examples. Okay, today we'll be looking at this Lambda function example and this cloud function example. Okay, just to give you a heads up. Let's get started. Okay. Somebody said git bash. So git bash is another tool that you can use to, instead of Sigwin, you can use git bash to do the same thing. So you need putty. Actually, you don't need putty. You can also use just Sigwin or git bash. Yeah, I mean, so folks who are using Windows, if you have the Windows machines here, you can come to me during the break or during the office hours, and we can work through appropriately. Okay, if you're stuck on it. So this Jupyter I'm just running locally. Okay, so this is just the same PEM file or the secret key file that we have from last time. It's the same situation. I'm just resuming it from last time. But this is just so that I can show the terminal in the browser. There's nothing specific about this. We don't have to run Jupyter locally. In fact, I'm going to run Jupyter on the remote machine. Okay, let me just so I just opened a terminal and so I copied the IP address earlier, right, 2 seconds ago. I'm just gonna use the command here, okay, which is SSH. You don't need the extra -o identities only. Typically, you just need -i. Just means pick this particular. The identity is provided by this particular key that we have that I got downloaded last time. You would have your own key, mykey.pem or something, and then the default username is Ubuntu because we picked an Ubuntu machine. If you picked some other machine like Amazon AMI or some Amazon Linux, then it's called EC2-user. Okay, so don't get stuck on that. But and the last part I just copied from instance details. Okay, the IP address, and for you it will be different. So I logged in, and you can see that we are in that machine, and the front part, this base, is something that we got because we installed Miniconda or Anaconda. Okay, and it's just showing which environment you are in. You can change that environment to, you can create new environments and switch over to them. But for simplicity, we'll keep the environment as base. But then in the notes, we talk about creating other environments. Okay, environments are just separation of concerns. So if you are a Python, let's say freelancer, or you're a machine learning freelancer, and you have multiple projects with multiple clients, and they have different requirements. Like one requires PyTorch, one requires scikit-learn, the other one requires something else, right? So you don't want to mix all the packages, okay? Because especially, for example, maybe after installation, you need to containerize it, then it'll have all the copies of other unrelated packages also if you're trying to containerize. So it's good to have separate projects. It's like project specific packaging. Okay. Okay, so now we're here. So actually I was gonna So actually, I'm just going to run exactly what it says here. So let's see. Oh, no. Okay, it doesn't show the command for Conda. Is it? Okay, so the actual, so since we are using Conda, which is this mini Conda distribution, then the command is Conda install. It says there Conda forge. It just is a way for it to know where to pick up this Jupyter Lab package. It's very similar to pip install. You can also use pip install alternatively. They just influence different things, different ways, subtle ways. So for simplicity, let's just go with some default choices. So Conda install this. Yes, I mean difference in the sense that Conda. So if you do it this way, Conda remembers. I mean, it keeps a registry of what all it's installed. If you do it via pip, sometimes there could be conflicts, or sometimes packages may get updated without Conda knowing what's the current status of all the packages that you've installed. Okay. It's not a big difference. I mean, both will install and you will be able to access Jupyter Lab. It's just it's good to give one program a full idea of what all packages are there, so that it can resolve. The whole point of this packages manager is to resolve dependencies. So if you want to install Jupyter, you can see that there are like 20 different things that need to be installed and different versions of them. So that's what these package managers deal with, right? So let's install them. Install this. Okay. Let's see. Okay, it actually installed. So what we need is a command to. So Jupyter Lab also cares about security. So by default, if you run Jupyter Lab, it's going to give you some token and you need to use the token and all that. Instead of that, we can try to create a password so that we can just use the password-based login. So let's try to do that. Yeah, so these instructions are actually for older. It's not for Jupyter Lab. It's for Jupyter Notebook. But let's actually try.
Password on the server while we are running this.
It's just a password. Just it's a weak password for front for just the Jupyter service. The server itself, it was passwordless access, right? So you can actually change the password for your server username. Yes, 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 yes. No, local, you can set up a password if you want. Yeah. So let me actually say what the issue is. So sorry, let's close this. Okay, so another thing I'm going to do is actually I'm going to use another tool called Screen. So let's see if Screen is there or not. But it is there. So okay, so screen is a tool, and there are, as I said, for everything there are 10 different tools to do the same thing. Screen is a tool for you to virtualize your terminal, so that if you get disconnected, you can do screen minus, screen space minus resume, so that you can get back to the same terminal state that you were in. Okay. So what do I mean by that? So let me do screen. Okay. I can give a name, for example, screen. Let me call it Jupyter as a name for this particular um, terminal that I'm creating. So this is a virtual terminal essentially. So you will see that nothing much has changed. It looks exactly the same prompt. But if you're on Windows, or if you're on Linux, you can do Control AN to see. Okay, can't see because I need to. How do I minimize this bar here? That's just screen. Okay, so if you do Control A, so you can see here it says no other window, right? So that's, I guess, a minor indication that we are in this virtual terminal. So don't worry about that. So if you're in screen, if you type exit, screen terminates. Okay, so screen minus S Jupyter is just gives a name to a virtual terminal. In this, if you run, so if you let's say type a program like PWD. Okay, PWD means print working directory or present working directory, what do you want to call it? So that's the directory currently I'm in. I can do Control A D to Control A simultaneously, and then press D to detach from that screen. So Control A D. I have detached from that virtual terminal. Okay, so now the CD command, the PWD command, which showed something, that's still there. It's just that I have kind of removed myself from looking at it. Okay. Now what I can do is screen minus R, okay, is resume, to that, connect to that particular, I given a name, right, Jupyter, and just resume to that. If I press enter, I'll come back to that thing that I detached from. Okay, so in that, the thing where I had earlier, I had the PWD, you just get back the same view. So it's just a way to detach yourself from a terminal, okay, while the terminal is continuing to run and show the same state as it was before. Okay, so why do we need this? We need this because we want to run Jupyter server or Jupyter service, okay, continuously on the server, even if we detach, even if I close my laptop, even if I turn off my laptop, even if I log out, like I did an SSH, right? Even if I do exit and exit out, Jupyter Lab, I want to keep it running. Okay, this is one way to do it. There are actually many other ways. As I keep saying, there are many ways to keep Jupyter server running on the remote server, but we'll do it this way. Okay. Yeah.
Why didn't we just do page install Jupyter Actor so that the could have installed all the instances?
Yeah, we did almost same thing, right? So we did almost the same thing, right? So
no, I mean, right now we did this lab with Jupyter Lab, right?
Yeah.
If we could have done page install, that could have installed all the instances.
Yes, it might have. I mean, yeah, we just had to run this. Is that what you mean?
Right. That's perfect, right?
Yeah.
But let's just say I wanted to use Jupyter Notebook.
Yes.
Rather than using
yes.
So just
then
both of them.
No, then it says here that if you want to run that, right? Pip install notebook would install Jupyter Notebook. Forget about lab. Right? I mean, I'm just saying you can follow anything. I mean, there's no big discrepancy. The only minor detail with Conda is that you can always use pip commands in Conda as well. It's just that Conda, is a dependency resolution aspect may get messed up if you use both pip and Conda in a Conda environment. That's all. but it's not always the case. But for for good professional practice, it's good to stick with one or the other. Yeah.
And you use screen command before execute? Or was it after execute?
No, the screen command was just so that I can just start Jupyter server on the remote machine, so that now we can forget about SSH in the remote machine and just look at Jupyter from remote machine.
Oh.
So okay, what are we trying to do in this past 15 minutes or so, and the next 5 minutes or so, is just try to set up Jupyter server on the remote machine so that it keeps running forever and we can always connect to that rather than directly to the terminal. So far we have been trying to log into terminal, right? So I think in fact, let me exit from here. Oh, sorry. Okay, that exited there. But okay, so every time I want to connect to the remote machine, I have to do this, right? Instead of, so if I do this, but I have to do this in a terminal setting, right? I do this, but I get a terminal prompt, right? Something like this. I don't want the terminal prompt. All I want is the Jupyter server directly on the browser running on that machine so that I can directly work with Python. That's what I want. That's the, I guess, the goal. That's because once you have the Jupyter thing, all the notebook, or see all the details in our chapters, it will be the same commands, the same workflow and everything for everybody. Okay, you don't have to worry about Windows versus Linux versus Mac OS or anything like that. In Windows?
Yeah.
There are 10 ways to do the same thing, yes. Oh yeah, I think in the announcement I sent you, there's a Windows subsystem for Linux 2. It's a way to also do these Linux commands and have a terminal. Python itself, I guess, gives you Python terminal.
Yeah.
When you install python.org Python. Anaconda will also give you terminal. Git bash will give you terminal. Cygwin will give you terminal.
It's pretty much the same. We don't have to know.
They're almost the same, yes. It's just that you need to be familiar with one tool at least. Don't worry about installing all of them. Pick one. And if you're confused, just ask one of the teaching staff or your friends, and we can. Some of you who have explored these may know the pros and cons of one versus the other. Okay, I guess let me come back here. So if I type this will not work because I just exited from screen before, so I need to create another screen session. Let's see. So if I do Jupyter Lab, the issue currently is that it's going to run locally and give you some token. Okay, so this is something that we want to avoid. Okay, so these types of token ideas. So let's actually avoid, as in like at least get over it, because it's running on that machine. Okay, here the local host means that computer, which is AWS machine. We want to somehow access it via the way we are doing it here, like not here, sorry, the way we are doing it here, like this localhost 888 is running locally on my machine, right? So I want to somehow deal with that. Okay, so the way to do it is written in that notes. Closes. Okay, let's actually skip the password stuff for a second. Okay, press enter. So what we're also going to do is go to this, go to our EC2 instance, go to security, and click on the security group. Actually, we don't need this. Sorry. Sorry, yeah. So actually, sorry about that security group stuff. We're actually gonna just execute the next command. Okay, so let me properly create the next command here. So what we're gonna do is, it's gonna, so we ran Jupyter Notebook on the server, it's running at localhost 8888 of that server. Now what we're going to do is make that appear as if it's running on my local machine at localhost 8889. Okay, so when I hit localhost 8889, there is what is called an SSH tunnel that's formed. That's gonna try to via SSH port to number 22 is gonna hit the AWS machine. In that machine, once it enters port 22, it's gonna say, hey, what's happening at 8888? The Jupyter server is running. Let's now grab its interface and all that. Okay, so I don't know what the exact IP is for me. Okay. So this is going to port forward basically from the remote machines 8888 to my local machine. Let's run this. So here I'm on local machine. You can see it's a different Conda environment and so on. This is my just local machine. I think I need to add these after the. Oh, that's not correct. This is not the right IP address. Huh. Let me debug this. Okay, I think I have hit a lock here, so let me just quickly try to see if I can fix it. Sorry. Okay, so the right command is just the ordering of the uh, it was just the ordering of the uh, text. So it's basically first you want to certify that, hey, this is the PEM file, and then tell what is the port forwarding. That's this part. Okay, so I just reordered some command line arguments there, and I ran this code, ran the script. Okay, so this particular Jupyter interface that you're seeing, this is the first time you would see if you ran Jupyter Lab for the first time on your machine as well. Okay, now this interface that you're seeing is actually the interface because we ran Jupyter Lab on the remote machine. Okay, why is that? That's because of this port here, 8889, is exactly so our local port 8889, as in this local machine, your laptop's 8889, is getting SSH tunneled through port 22 of that remote machine to port 8888 of the Jupyter server. Okay, so that Jupyter Lab server, through a couple of hops, is being shown as localhost 8889. Okay, this is different from, if you look at the URL here, it's 8888 because this is just locally I'm running it. Okay, and this is just my local Anaconda installation. Here it's saying, yeah, here this is the first time if you run it, this is what you'll see. So now it's token-based authentication is enabled. So you can either set up a password. So instead of a command line based setup password that is there in the notes, you can set up a password here to set it up. You just need to pick up the token from there for the first time. I exited from there, but that's fine. We can reconnect. And then if you do screen minus R Jupyter, you will see the token. Okay, this is the token. So this is exactly the utility of screen. You come back to the same situation you are in, even though you kind of close everything. So the token is, I guess, this string here. Okay, so I know it's a little bit messy output here, but all the tokens are the same. Okay, wherever you see a word token, you kind of see the same string. So that's the string you want to copy. Oh, copying is hard. Let's try Control C. No. Okay. Okay, I can't copy here. I have to use, no. Okay. What a predicament. Okay, let's try. Pen and paper. Who's suggesting pen and paper? Okay, let me try something. Okay, somehow it worked out. So let's try sharing that again. Okay. Yeah, I copied the token and then some. Okay, so now this, so I just gave some, okay, I should remember the password. Okay, so now this interface is actually running on the Jupyter server. Okay, so this interface here, sorry, on our EC2 machine, and you can see that, for example, right now there are no kernels running, right? So I can say, okay, let's create a new notebook, And in the interface, you'll see, let's actually see. Yes, see, you can see that it's saying saving file untitled. So this is going on the server side. So now what you can do is, this is inside a screen session. Again, so remember, you should not exit the screen session by, there's an exiting the screen session in a particular way, which is Control A together and then D, the key D. Okay, so Control A, D, sorry. Control A, D will detach. It will show actually detach from Jupyter. I mean, you'll see some numbers, but dot Jupyter. Jupyter was the session name, that the screen session name that we gave. Okay. Now we have detached from there. Okay. Now if I exit from the machine, the remote machine, I've exited. So now I'm completely out of that machine. Actually, we don't probably need this either. So we don't even need the local Jupyter thing. Okay. So okay, we do need it for one thing, which is that SSH port forwarding idea that I just showed. Oh, how is it running? Because it's the server is always running. That machine was always running, right? It's like I turned on the machine, remote machine, it's running. On that machine, I just showed you one way to run a program forever. I mean, till you reboot the machine or turn it off, right? It's like I keep my Windows machine at my home on, and then I can always keep some program running there, right? So that's what I've done here. Okay. I just opened this back because I wanted to remember this, remember the string. So what you need, okay. So what you need to always connect back to your remote machine's Jupyter is that string that is the string that I just removed, but I can paste it back here. The string, right? So once you have the string, as long as you have git bash or sigwin or any of these things, and as long as you have your pem file, okay, as long as you can run this command, you should be able to access Jupyter, which is running on your remote machine anytime. Okay, whether your local machine is running some program or the other doesn't matter. Okay, so on your, if you are especially on Windows, okay, you should not care about installing anything on Windows at all at this point. I mean, except for some program to run this command. Okay, and it's completely secure. That Jupyter thing, that machine is as secure as it can get, except, if you look at the interface, if you look at the security group, you can see there are two ports that are two sets of ports that are open to the world. Okay, so the 5000 we just opened because Flask by default runs a web server at port 5000. Okay, so what is the concept of ports, right? Ports are, just think of the ports exactly as physical ports, like in a port in a city like LA or Boston or something like that. Yeah, so ports are through which the computer can interact with other programs, other people outside the computer, humans or other machines. Okay, so the other machine generally makes a connection through a port. Like for example, if I do google.com, let's say Google server, the search engine, is in a single machine for simplicity. When you make a request, you go to google.com at port 80, okay, or port 8080 or 443 or whatever. There is a specific port number where you make the request. And then on that machine, the program running the search engine knows, hey, there was a request that came at port 80. Let's route it to the appropriate program behind the scenes. And that program will say, hey, let's show them the web page. So port 5000 is where Flask by default, for at least for development purposes, kind of shows your app, shows whatever you're trying to do. Like we saw the app architecture last time, Flask architecture last time, where there was, for every route you can have a function. The function can return a string, the function can return a prediction, the function can return a HTML page, whatever, right? So port 22 is where SSH connects to that machine. And then Jupyter Lab was running at 8888. You kind of, that long command was just trying to say, hey, 22, jump over to 8888 so that I can see Jupyter Lab locally. Okay, so that's how we are seeing this Jupyter Lab. And also on our side, the SSH command is saying, hey, whatever you connected to, on our side, just use the port 8888 so that I can see it on the browser. So it's doing a lot of complex things behind the scenes, but with just this command, of course, you need to have the PEM file or equivalent if you're using a different vendor. You should be able to get to a Linux-based machine with Python. And once you are here, all the commands of the course kind of, you just run it on this interface. Okay. Sorry, that took a long time, but any questions? Or you want me to send the commands that I used today? Yeah, I mean, so let me just say D for detachment, discharging from screen, and then to attach -R works because if you only open one screen session, then by default it'll attach to that particular Jupyter, but that session. But you can type Jupyter if you want. So once you do so before detaching, you do like here, you do whatever you want in that terminal, right? In particular. So this is what we did, and then the long command is something I myself don't remember much, but at the top of my head. But this is the command. Okay, this is there in the. So the only extra thing I added is sorry, this part, which is this part is extra, but otherwise this command is the same as the command in the notes. Okay, so the only thing is so the reason why the extra thing is there is because I have other key files, and so it confuses between other key files. But for you guys, if you're trying it for the first time, you don't need that extra, the thing I've highlighted. Okay, so this is the just username at IP address. So whatever IP address is relevant to you, you should use it. So did I use any other commands other than this? No, right? Okay, so we have so actually we can run. So these are the 4 files or directories in that folder. Okay. Actually, we can also run the terminal there, which is which is the same terminal that we were doing it via our own local Jupyter. But this is a remote machine. Okay, so you can see that same thing here, and the untitled file that we just created is there. So yeah. So any questions about this other than the concern about commands? So yeah. Yes, that's what I was doing, and I backtracked. Remember, I was trying to open one more port, which was 8888 right here, so that you can directly connect it. But then that will be publicly accessible, and so the security will be as weak as your password that you chose there. No, I mean then you'll have public IP, right? So remember, we have a public IP for us. So for example, we ran. So let's like last time, we remember we ran a Flask app, and we're using the public IP colon 5000 to access it. Similarly, when you run Jupyter server there, you can access the public IP colon 8888 if you want. If you open it here, okay. I mean, this is a quirk only with AWS. I mean, different vendors have different ways to do this, so that's why I don't want to spend too much time there. You don't have to tunnel and connect. Tunnel and connecting is just a good safety. Yeah, and this is something different organizations will have their own protocols. Different organizations in the sense that whichever company you work with, they'll have different security practices and security procedures that you need to follow. Okay, and one simple procedure that we follow here is that you need to VPN to access certain services, right? So you need to be on UIC's IP address range to be able to access some services. So you can do the same. So not you, as in companies do the same. So that also is one mitigation, so that publicly people can't, everybody else beyond the organization don't see this. Okay, so there's a question, how did I get the localhost 8889? That was because I used it here, right? So instead of localhost 8889, if you say 10,000, okay, instead of 8889 10,000, then you just have to go to localhost 10,000 here. Okay. So that's how I got. I mean, since I specified that while tunneling, I'm using that. Is that clear? Harshit, I think. Doesn't work for me. So if you've run the command several times, then they'll say port is busy, or not port is busy, but I don't exactly know what the command is, so what the error mode is. Try a different port. If the port is the issue, try like 10,000 or 9,000 something. Yeah, if it's already in use, just use some other port. Okay. For now, I mean that's not the fix, but it seems like you tried the command and it don't really. So if you've already run it and if you try localhost 8889 and it's not connecting to the remote machine, then ensure that on the remote machine you are running Jupyter Lab at 8888. Okay, that it is running there and it is running at 8888. Okay? It is running there right now, although I have disconnected it. I've disconnected pretty much, right? I have not logged into so this is, by the way, the remote machine. So I'm not logged into my local yeah, I'm running Jupyter like remotely, without me doing any hand holding for Jupyter server. Yeah, is it clear? I don't want to confuse people. We just achieved something simple, but at the same time this is like a delta simple, but at the same time for some people who are not very familiar with command line, I can totally see why this is like a huge jump. So people, so I just want to get a sense, is it a huge jump or is it too simple for you guys? So for you it's fine, but what about other people there? So once you're here on that remote machines thing, then as I'm saying, it's all we're going to use the same commands, no variation across windows and all that stuff. So you can just pretty much focus on the course material. Yeah.
So, in case of Windows, which type should we use? The .pem or .ppk that would be?
If you use ppk, then you can only, so PuTTY is only for SSHing into a machine, but this port forwarding business, you need something like git bash. So there you can just use pem file, I believe.
Is there any specific directory that pem file is applicable?
No, it's just randomly in my current directory, right? So it doesn't have to be in particular directory. Wherever it is, of course, you need to root, you need to refer to it properly. Like here, I'm just, so in this command, I'm just assuming that the pem file is whichever directory you're running this command from. Okay, so because I didn't write, like, basically it's like / means the current directory. So instead of that, if it is in / user / Teja, I don't know how it is in Windows, but if it's Mac, then you will have something like this. Then you need to have the appropriate root here. If you're not running it from the same directory. Yeah. Okay. Any other questions? No. Okay. Let's actually get back to our topic. So I want to quickly not recap, but at least mention these headings. So what did we skip, right? So last time we skipped, so we did SSH. Okay. So basics were just what's a web server and all that. In third module, we just talked about SSH, which is what, the key tool that we're using. That's one new command line tool that you're probably introduced to, some of you. Firewall was just exactly what you know from Windows, Bitdefender or something like that. It's the same idea that you want to have for any machine. Okay, you don't want other people to kind of get into that machine and do nefarious things. And setup of Python, which is exactly in this notes we are just using Conda based Python distribution, but you don't have to. You can use any Python distribution. Recommendation models is something that we did not see, but it was just a PyTorch example model. This is something that you do offline and build that model. At the end of the day, what is a model? It's just a function. Okay, it has to given an input, feature vector or something like that, image. It has to spit out a class or a recommended content ID or a string or whatever it is. Okay, so that's all it, from our purposes, from our perspective. So and the last class we tried using the Flask web server. So we understood, how do you talk to a web server, just like we talk to other people, English or some other language. We talk to web servers using HTTP protocol, like a GET request or a POST request. And we saw that. So let me just. So if you import requests. So request library can let you make get or post requests. I think we saw that um, last time, so I'm not going to repeat it. Maybe we'll repeat it when we set up our serverless functions. And Flask apps. Flask app, again, the big concept, we ended it there. Flask app, the big idea is with this micro framework and most of these types of micro framework is that they just map a URL route to a function. What is a function? A simple Python function. Okay. So I think let's look at. I'm just going to look at the simplest example that we actually deployed last time. So let's not worry about this these parts. It's just we need a model to make a prediction. Okay, so that's what that is doing. So let's ignore lines 5 to 13. So this is a Flask app where we're just importing the main module and a couple of helper functions, JSONify and request. So here's the key thing, right? So it's saying, hey, whatever is the IP address, and once you IP address slash, okay, and if you pass on the feature value, so this is a simple regression situation. So feature, so there's no feature vector. There's only one value, one input, one-dimensional regression. So it's just saying, hey, is in x is a part of the x part of the input. If x is part of the input, what is the value of x? That's I'm returning that. Okay, hey, here's the x that you gave me, and I'm calling model on that x. Okay, so that x typically happens to be a string. Okay, in this protocol, so I'm just converting into a float. Okay. So the key thing happening is the URL, whatever the IP address slash, is getting mapped to this function predict. Okay, instead of that slash, if I slash about me, and then I can have another function which says, hey, hello world or something or whatever about the author of this code, right? So each URL slash some about home services, whatever, like typically you will see. So they or slash predict, for example, can go to any function like this. Okay, that's the key idea behind this and these types of frameworks. Okay, this is the simplest one of them. Yeah, actually let's run it, right? So I don't so we are in that same directory, so actually get status. I did modify something last time. So by the way, git status, just so how did I so one quick digression. So git status just means I just checked whether my copy of the code is different from whatever copy I downloaded from this place. Okay, so it's just saying I slightly changed this plus simple regression, but that's fine. So let me mention let's actually go into that directory. Last example. Okay, let's look at this function. So it's almost the same function. Okay, so let's actually everything is in AWS server. Okay, so you don't have to worry about whether in Windows, Linux, Mac, whatever. Okay, so we don't need get model, or maybe we do. Actually, we do. So let me keep that. So I've slightly changed the code. Okay, so made it a little bit simple so that there is no pickle and all that. So I'm just creating a regression model. Okay, so this model here is a function which takes a univariate input and produces a univariate output. Okay, then the model is very simple. It's just ax plus b or whatever, slope times input plus intercept. And here's the key thing, right? So here's the Flask part. So I'm instantiating a Flask object and calling it app. And then what I'm doing is here, this is called a function decorator. Okay, it's an advanced feature in Python. And if you're a beginner in Python, you might not have seen decorators, but they are just a nice, it's just a syntax. It's saying @app.root. Okay, something like that. So what it does is takes whatever function is following it and adds some extra bells and whistles so that it can actually work as a web service. Okay, so that's what it does. Very informally, I'm saying you can look up what are function decorators offline, but the core idea here is that it's saying, hey, root starts with some IP address. That's the default. Your server may be running at some IP address or some domain name also. After that IP address, if somebody types /predict, okay, then this function should be invoked. That's all this whole Flask business, this whole thing is doing. So let's actually run this. Regression and Python Flask regression. I don't know. Called service. So let's run it. And it's running at although it says it only shows me the internal IP address colon 5000. We know what the public IP address is, so we can just go to what is the public IP address. For me, it was actually, you guys can also access it, this part. So this was the IP address. Okay. Oh. So /predict. So this was my IP address. For you, it will be different. But if you wanna really access, you can also access now with this IP address. So /predict got mapped to that function, and the function says, "Hey, input was not passed," and so we are not successful. Okay. So now let's actually go back there and change the function. Okay. So let me actually add another. Okay. Oh. I don't want to do anything complicated, so let's just do this. Okay, so now this is a different route, right? So MLOps is going to get mapped to this function. This function is just returning a string. So I don't know if it's going to work. If not, we'll restart it and it'll work. Ideally, it should. Okay. Oh, okay. There are some lot of bad requests going on. Anyway, so this is what I mean. We just added this, and so it routes to that. So this is a simple idea, okay? And this is enough for us for now. I think if you want to get more into web frameworks, there are other web frameworks like Django is very popular for web app development. So you can use that as well, and it lets you interact. I mean, even Flask will let you interact with a database and do lots of more complicated things. But here, the idea is simple. A route should be mapped to a function. In the function, you can always call model.predict. Okay, that's as simple as that. Okay. Yeah. So actually, where were we? Yeah, I was just recapping. So, and that's it. And so that's a quick recap of lecture 1. Okay. So lecture 2, we'll take a short break right after tell you the outline. We are going to do the following. Okay, we're just going to kind of briefly discuss serverless idea a little bit more, and then we'll try out 2 serverless exercises. Okay, one is with Google Cloud Functions, the other one is with AWS Lambda Functions. Okay, they're just names for their serverless offerings, but they do both the same thing. And so we'll try. Maybe since we are sticking with AWS interface, so maybe we'll start with AWS first and then switch over to Google. Okay, so that's what we'll do. So let's take a short break for 10 minutes.
I remember training the model.
Crash. Yeah. No, keeping Google Colab alive is different from keeping our servers, which we control 100%. It's different because Google Colab, you want to keep it online for a long time. It's unclear how to do that. I mean, people have some tricks, but I'm just saying that the trick that we see here is not the same as that.
Yeah, but what I think it would happen in
Oh yeah, if you are on a server. Yeah.
Even if you turn down your machine.
Okay, so what I was doing is just try to get ImageNet example running so that you can see some other examples. yeah, this is the actual web page. Okay, and this is something is basically a default model where you can upload an image and it will tell you what the class of the image is. Okay, so actually you guys can try it. Maybe it'll crash. This is the IP address, and if it doesn't work, let me know. Okay. Okay, let's look at so the anyway, I just tried it, but there's a cat there. I don't know if you guys saw it. Um, yeah, I don't think it's displaying the cat itself, but I just tried out a cat image and said it's Egyptian cat. But anyway, that was just an example. A couple of more examples in the there's the food one. I think I was there was a pizza example that was you guys might have seen during the break. So that's Flask food API. And then you can also try the weather example where it's querying for weather if you give the name of the city. Okay. And I think Zoeb tried it out. Seems to be working. So you should try it out. Okay. So let's actually move on to um, the next set of topics. So yeah. So what is the problem it's trying to solve? And this is a brief recap. And I know I mentioned it earlier. It's a brief recap. What is serverless service trying to solve? So we've already so at this level we've already solved kind of deploying a machine learning model, because if you have a trained model, like for example here it's an image classifier, you have a simple web page like this, and anybody can upload whatever their input image is, and they can get a label, and that's just for classification. But you can imagine object detection or many other things that you can do just by setting up a web page like this, a web server like this. So what is the issue that serverless technologies can solve is that they kind of minimize the amount of behind the scenes stuff that we had to do. We had to spend like last lecture and this lecture so many hours basically to get to this level, right? So you can actually get to this relatively quickly if you're only concerned about your script and not everything else that's going on with the machine, with the commands, with the SSH and all that stuff. You don't need to do that at all. And so that's where the value proposition is. So basically, uh, you know, we can take care of. So the problem is we have to take care of servers and provisioning and all that. And the question is also, if we deploy it, hey, should we only deploy it on one machine? Can I do the same thing on another machine in case there is a lot more load or requirement of me having a prediction model? you know Also, there could be time to deploy it. We spent like 2 lectures just to get to that ImageNet example, for example. And basically the idea is, how can a single dev or a single business analyst or a data scientist, how can they scale? How can they use this automation technology to quickly deploy things, right, that they build, they train, or whatever. The solution that these guys pitching, people behind serverless technologies, they say that you can abstract away many of the server details, okay, so that you just focus on your function at the level of your function, okay. So the software behind the scenes automates the underlying machines, which are the servers, scaling the machines up and down. So in case you, instead of 1 request per second, you're getting like 10,000 requests per second, maybe you hit the front page of Google or something. So you can scale up, okay. And also it can balance, especially for example, if you have multiple machines serving making predictions, then you will have to deal with load balancing, and we'll see that later. Load balancing just means, hey, one machine getting 10 requests, one machine not getting any requests, other machine getting 100 requests. So there's some balance that needs to be built. So that all happens seamlessly behind the scenes. From our perspective, it looks like as if one function, but behind the scenes, depending on the scale you need, there could be hundreds of machines. and they're all balanced, and they're all able to respond to incoming prediction requests very seamlessly. Okay. Um, yeah, I think we have already discussed this, so let's actually directly jump over to some practicals. So before that, I also want to quickly show at least the high-level diagram or what are the moving parts here. Okay. Just like in the web servers, there was not much of a moving part. The server side was just a Flask app, and behind that there was a simple model, right? So the Flask app, setting up the Flask app and all that took time. Similarly, for serverless, still the same client. Still, the client could be a browser, the client could be a request package, the client could be a curl program, it could be anything in any user. And the way serverless technologies work, at least for example AWS, is that the two parts. Okay, um, for AWS as well as Google, the one part is called a trigger or a gateway. Okay? In Google it's called trigger, in AWS it's called gateway. It's just a way to map uh, the IP address to the function, very similar to what Flask does. Okay, in Flask, we already got the IP address when we started a machine, so IP address was already there. Flask did the mapping from IP address slash some string to a function. Here, what the gateway slash trigger block does is it maps the IP address to the actual function, because you only control the function, so it lets you map the IP address to your function. Okay, and you only touch the innermost block, the serverless function. It's literally, when I say serverless function, it's just your regular Python function. It's like def predict with some input, and here's my prediction output. Okay, that's as simple as that. Behind the scenes, the outer block is where AWS or Google or Azure or whatever this vendor is, they take care about scale, security, resiliency, all that stuff. Okay, so it's very similar, except that the one single block that you saw in the previous slide, where we were doing everything from scratch, it's abstracted away to setting up a gateway so that it can map to the appropriate function and defining our function. Okay, and those are only two parts. So if you look at the kind of tools needed, we already kind of touched some of these, but you might need an account. I mean, depends on which vendor you want to try it out. In this lecture, the scope was mostly restricted to GCP, Google Cloud, and AWS. But if you want to try it on Azure, you will need Azure login and all that. GCP Cloud function. Once you have a Google Cloud account, you can just directly access Google Cloud function. AWS Lambda is another tool. I mean, these are tools, as in these are serverless services themselves. And command line interface, we will try to skip them for today. I think we've already seen quite a bit of command line today, but there are a couple of command line functions, so command line programs, okay, which are used to interact with resources on these cloud providers. Okay, so AWS is the name of the command, just like ls, pwd, mkdir. These are simple commands in Linux. Similarly, AWS itself is a command, AWS space create a storage. It's like S3 bucket or something. Is a command that you can give, and it will immediately go talk to AWS. Of course, it knows your user credentials. It will create a bucket, a storage space for you. Okay, or AWS create an EC2 instance will kind of create an EC2 instance for you, roughly. Okay, so but there's our CLI tools. We will probably skip them. Try to skip them for today, and experiment with both Lambda and maybe if time permits also Cloud Function. Okay, for this, as I said, let's look at the example. So there's a very simple Lambda Function example. These are the three, I guess, files there. Two are JSON files. They are actually just helper files. So if you open, for example, movie dictionary, it's just a dictionary of, hey, movie number 1, what is its name? Movie number 2, what is its name, and so on. Okay, that's one helper function. And top n, we are trying to kind of simulate a recommendation system. So top n is just what are the top recommendations for a user. Okay, so input is a user ID. So so think of feature vector. So in typical machine learning flow, you give a feature vector, let's say 10-dimensional feature vector, you get an output like class or numeric prediction. Here the setup is slightly different. Our input is not a feature vector. Our input is a user ID, because for that user ID, we know what movies I saw in our backend already. So the user doesn't have to send, hey, these are the movies I saw, tell me what the prediction is. Right? That doesn't make much sense. User's client device, let's say their laptop or their TV or their phone, will just say, hey, this is my user ID. And behind the scenes, these companies already track what all is the user behavior, how much the user engaged different movies or something like that using other programs. Okay, so that data is already there. So given the user ID, the model will just pick up, may pick up in real time the actual engagement data and make a prediction. Or in this simple case, we've already created the predictions for each user ID. So we, given that user ID, we'll just pick up what the predictions are and then just show the movies. Okay. And actually, so as you can see in this code base, there are two helper, I guess, is it this data files, and there's one py file. Okay, so the py file looks long, but it's actually very similar to the uh, Flask app, except that it only has one function. So line 6 onwards is just one function. Okay, so there's one function and there's some import JSON, just for some auxiliary functionality. So it's just one function. This is the only function that is our responsibility. Everything else is taken care of by this AWS Lambda service. And with that, we can deploy this recommendation model. So it's not really a model, it's a little bit of cheating, because here the model has already made the predictions, and those predictions are available in a JSON file. I mean, instead of that, it could be available in a database, okay, like a SQL database or a Postgres database. Okay, so it's the same idea. Okay, here for illustration purpose, we're just reading it from a file, but you can read it from a, just like in the Flask examples, we were able to ping another machine to get some information. Here you can ping another machine to get that data. Okay, pre-generated data, pre-generated recommendations. So if you look at the function definition, it's very similar, right? So it's just saying it has slightly different function signature than Flask. Flask, it says get, request, so it says methods, get, and so on. Here it's saying event and context. This is just standard signature for AWS Lambda. We are just reading some existing files, and then we are saying, hey, if there is a body in the object called event, then just set it to be, just make the event body field to be event itself. And then if event is not none, then you read the JSON payload that is available. So it's just a bunch of, I guess, glue code to get the variable, to get the user ID or get the information to make the prediction for. Okay. So that's all. It's just some cleaning up of the event variable that was passed in. So how is the event variable gonna get passed in? Exactly this way. So the gateway, when somebody sends a, hey, here's, give me for user 100, give me the predictions, gateway is going to say, hey, call this function with that 100 available inside the event object. Okay, that 100 variable, user ID is equal to 100 variable, 100 value available inside the event object, and that's what we are parsing. Okay, this is just a little bit of parsing of the event object, and then says, hey, in that, finally what we get is basically a dictionary. Okay, the dictionary should have ideally an UID, which is a user ID. If user ID is in the event object, which is a dictionary, then we'll say, hey, it is there, so let's set success equal true and get the response bus, which is get the dictionary of movie names for this person's top n recommended movies. So some simple logic here. And if that's not the case, we'll just say, hey, there's no it's unclear sorry, if that is not the case, we're not addressing, and we're just returning the whatever we got. Okay. So right now we're just doing a simple lookup here for illustration. What's it? Yeah, I was gonna mention that. So deploying the model is doable. In fact, last semester, one of the team's challenge was to deploy a model. The challenge is basically that the moment you use scikit-learn, let's say, scikit-learn depends on NumPy and SciPy, and they are huge files, and you need to package them together. And so there's a little bit of complexity. Here you can see that I'm not importing anything. It's literally JSON. But if the moment you want to import scikit-learn, for example, it just increases. It's written in the notes. I'm just not showing it in the live lecture right now of how to do that. And so you can do that. But if the moment you have a really large model, like a 1 gigabyte model, then it's better to not do that inside this function, but have another machine so that this function can call somewhere else to read that model or something like that. I would say for really large models, this probably doesn't make sense. Only because they have restrictions on how big this Lambda serverless functionality can be. They don't want like a really expensive computation and really large memory to be used for something like this. These are really throwaway functions where you don't care about setting up everything else. You just want a simple function. Hey, give an input, produce something quickly without worrying about the rest of the setting up an EC2 machine and all that. Yeah. So here I'm not showing it, but you can actually make a Lambda function out of all the Flask examples that we have seen. Okay. All you have to change is instead of importing Flask and all that, you delete all that and just retain that predict function and just change the function signature so that the input is available in the event variable. Okay, like the way I'm showing it here. Okay. So we can do that. It's just I'm not showing it here. So is our responsibility clear? So the question is, how would you test it, right? So this is like, how do you locally test it? You cannot, it's not easy to locally test it. You have to iterate it out, as in like you try this function on the AWS interface and debug and see if that function works. And if not, then you'll have to, work that like that, because this is a little bit different from Flask, because Flask you can debug locally, for example. So is it clear what I'm saying? Yeah, it's just a default function signature that they have in on. Like we will actually set it up right now, so we'll see. Yeah, event and context, and event has that user ID if you pass it as input. Yeah. Okay, sorry. Let's actually try it. Okay, you saw the tagline, right? Run code without thinking about servers. So you have to think about something. So let's try. Okay, so on that interface, I just said create function. That was the availability. So let's just try this. So auto from scratch, that's fine. Function one. So here's the choices, right? So it's basically really just asking you to only think about what runtime you need. But there's also a limitation. For example, if you need SciPy, NumPy, Pandas, and all that, then you have to think a little bit carefully about how to introduce them. There are a couple of ways. Okay, there's this notion of layers that we will not discuss in the notes. There's also another way which is discussed in the notes, but we'll not see in the lecture right now because it's just too much detail. But there are ways to deal with dependencies also. Okay, so these are all the choices. Let's pick Python 3.9. Architecture details, let's not worry about it. Was it? If your function code itself depends on this particular computer architecture, then but right now I don't think, like for example this one, I don't see anything related to, it's just text files and nothing. So there's nothing here which depends on architecture. Yeah. Yeah. Instance is not available. Oh, okay, okay. It's not in free tier, but it is available. Oh, okay, okay, okay. Okay. I mean, it is available. That's why they're giving you the option, right? So you can choose it if you want. Yeah. Okay. Okay, okay, okay. Actually, for most of the code that we're using, it doesn't matter which architecture it is, because it's not very tied to the underlying instruction set. If I don't know if any of you or many of you know about this. There's a low-level detail at the at the level of a chip, like how does the CPU or the processing unit, the instructions, they are represented in different ways, and so they're competing architectures there. So ARM64 is one, x86 64, which is the Intel one, is another, and so on. Okay, so it doesn't matter for us for this example code, but it could matter for other purposes. Yeah, but good point. Yeah, thanks. So let's create the function. Okay, so I just said create the function, and by default it gives you some hello world function here. So let's actually work with that, and then we can kind of modify it to what we want. So to invoke the function with the test event, choose test, right? So let's actually test the function. So you can see the function signature. It's the same as what we have in our example. Basically, just saying, hey, return status 200 and say hello from Lambda. Okay. So let's actually test it. So you can see the orange button which is highlighted here. So let's hit test. Say create a new test event. There's some template here. Doesn't matter for now. So it's just saying if you pass these as inputs, what will happen. So first of all, this function, as you saw in the previous, before I opened this, it doesn't need any input. It's just saying hello world, right? So we can delete this and it will still work. But let's say we pass key is equal to key 1 value 1, key 2 value 2, key 3 value 3. It's like a dictionary. This is a JSON object. Okay. So let's create and then click test. Okay. So its response is, you saw the response when the function is triggered. So when the function is asked to respond, asked to produce an output, it's just producing the output that it's coded in there, right? So this is exactly what it's written here. Okay. So when you create this function, all they're saying is, hey, write your implementation details here, and that function will get executed. As simple as that. Yeah. So what we're going to do is something very simple. So we're just going to change this function to the function that we want. Okay. So, and also we want to trigger it from an external world, some external IP. Okay. So that's the gateway part that we're going to add next. Okay. First, let's actually just kind of concretize the serverless function itself, and then talk about how can we make it public to the world. Okay. So so when I said additional functionality, there's this you can see the layers here. So if you want if you want SciPy, NumPy, or Pandas or some things like that, you can add layers so that so there's some terminology that they're using. Okay, and it's actually very related to Docker stuff that we'll see next lecture. But if you're interested in more full-fledged models, then you can dabble with layers or some ideas that are in the notes. Okay. Yeah. Okay. So let's actually we can just copy this and paste it there. Actually, okay, I'll make it even simpler. So I won't even read the extra files, but those extra files just can be imported, can be added here. Okay. So how do you add it? You can just go to upload from a zip file or something, and they just show up here. Okay. If you want to do it manually, you can just add those two files here, but I'll skip that. So so top n is just basically saying, hey, for this user ID, there is some first top movie is 3 and the next top movie is 4. Actually, I'm not sure if it is the right notation, but okay. So anyway, this is the two dictionaries. And then you hit deploy. Okay, it says changes not deployed. I changed the function from before, whatever the hello world function was. You deploy it. Okay, now if I hit test, it should probably not work. Oh, okay. Yes. Deploy again. Actually, the test also needs to be changed, but yeah, success is equal to false because the test was just passing some random key 1, value 1, and so on. So let's actually create another test event. Actually, maybe the same one. So let's say UID, which is the user ID. I think there was 196 there, so let's just use 196 here. Okay, so now let's test again. Okay, we got some response. Okay, so status code 200 means something positive happened, um, which is this is the response that the server is giving. The function is giving. Okay, so the function is saying, hey, you passed a UID in 196. That user, the response responded, which is recommended movies are A and B. Okay, that's only because for 196 there is movie one with movie one with some score and movie two with some score. So movie one is name is A and movie two's name is B. But um, we can actually upload those files and have more realistic movie names. But let's not waste time on that. So the function works locally as shown here. Any questions about this part? We just copied the example from our MLOps code examples, Lambda function, just the whole thing. Okay. This is only to kind of get a sense of like how we change from the default hello world thing. Okay. And I said the way it figures out. So we passed in. If you look at the test, you saw we are passing UID is equal to 196. Okay, that is the so the function is expecting any client to send it not question mark UID is equal to something, but to actually pass a JSON object which says, hey, UID is equal to some number. Okay, so there's slight difference here, and we'll kind of get there when we connect it to an IP address and try it from a browser. Okay, so good. So the function works. Now what we're going to do is add a gateway or a trigger. Okay, so this the top part is actually showing what the block diagram, so what the blocks are, moving parts are for this deployment. So add a trigger. So we'll ignore the destination part. Add a trigger is exactly to expose it to the map. Use an IP address to map it to this function. Okay, that's all. So this test was all internal. Okay, so let's add a trigger. Let's call it API gateway. Okay, and I think we should create an API. And so API just means application programming interface. But for us, it's just I want a way to talk to this function through HTTP protocol. Okay, that's the English objective. And for that, we're going to say, hey, create a gateway, so which maps an IP address to this. It's called an HTTP gateway. For simplicity, there are some variations with REST and so on, some other variations, but let's take the default options for now. And security, we'll just keep it open to the world. Okay, so this is not a good security configuration, but for just testing for now, it's good enough. Yeah, we don't have to do any other change. Okay, let's add this. Okay, so we have added. So you can see that instead of trigger here, it says API gateway. So what it's doing is this kind of connects to this function one that we created. So now let's look at yeah. So it says API endpoint is this URL here. So this is not an IP address that we were using before, very EC2 machine. It's actually giving some random name string dot execute API hyphen the region, the data center region, Amazon, and so on. Okay, so let's actually see if it works. It says success is false. Okay, so it's actually got triggered, and then we didn't send any package, any data to it. So it said no response. I mean, it basically said we didn't succeed. So if you do UID is equal to 196, probably not work. So yeah, so you can see again success is equal to false. That's because it's not expecting a get request. In the previous examples, we were illustrating a get request. Okay, so which is how we were adding question mark x is equal to 10 or something. That's a get request. So we're gonna try a post request. So let's try using our Jupyter. We imported request already. So how do you make a post request? Does anybody have quick answer to this? No? Request.post and data. Okay. What is the I don't know if that should be string or not, or maybe it's a string. Okay, so I created a post request and I sent some data. So this is how you send some data to a post request if you are using Python. And let's look at r dot, I guess, status code. Oh, it actually is errored out. So let's see. For a reason. Okay, it's errored out. So let's see. Come back. Oh. I think I need to look at trying to see where does it show the logs. Not the layers. Monitor. Was it logs? Oh yeah. I don't know which timestamp it was, but let's see. This one? No. Can't figure out. Oh, it is. Okay, actually, what I'll try is let's see if Postman helps. Do I need to sign in? Let me actually make a curl request and see if that works, because I don't see what the error is and I can't figure out from here. JSON decode error. Okay. It should be. Is this the right? Expecting value S. Is this not correct? No, that's not correct. So I'm not sending the JSON thing properly, is it? Okay, so let's try one last attempt. Um, import JSON and here nope, it's not a string. Okay, I don't know how to ping the machine, ping the serverless function properly. Maybe I'll debug it. Oh, we already lost time. Okay. Okay, so I guess let me end the class right now. While I debug this, I might, it might happen that it's just a minute of work, but I don't want to consume too much time. So I want to quickly recap what we're trying to do. Yeah, let's just look at this picture. So this is just one example of a serverless service provided by AWS. All you're focusing on is this function, or okay, function one is what I'm calling it here. In that function, you can write whatever functionality you want, in particular model serving, if you which is what we are interested in. If you attach it to an API gateway, then you'll get that public URL like we saw earlier. But you need to just pass. You need to make post requests, which is where we saw an error. But with just that, you can actually have a scalable, secure, and reliable prediction service, in the sense that you are not worried about all that. You didn't even think about all that. But behind the scenes, AWS ensures that these Lambda functions are, have those service level guarantees. Okay. So this is something that a lot of companies use, especially for not for machine learning per se, but in general for small functionality that they like to have. For example, notification if their database system fails can go through AWS function, so that appropriate people on call can be notified and things like that. So small things are generally done on this. Okay. Next time, maybe early on, I'll quickly show a demo with Google Cloud. Just so it's exactly the same. Instead of a gateway, it's called trigger, and instead of a Lambda function, it's called a cloud function, but it's exactly the same setup. So we'll try that at the beginning of the lecture, and then we'll directly get into containers. And I would highly suggest at least have the Jupyter lab running on the remote machine. Of course, don't open all ports. In fact, I would also suggest not opening the port that we have, like port 5000, because 22 is secure because SSH, because we have a key based SSH login, so other people cannot access. But with other ports, you are reliant on that machine being patched enough, secure enough that no vulnerabilities have been discovered since some time. So have that. As long as you have this running, Docker and other things in the subsequent lectures will be pretty easy. Okay, pretty easy to try out. Okay, okay then thanks for listening.